All right, so up first, we're going to talk about oblique triangles and the law of sines. The reason why we would use law of sines is because we're not working with right triangles anymore, okay? But we do know some congruency information. So we know that if we're giving an information of side equals side, which is two sides in their connecting angle, we can find information about the triangle. If we're in the position of angle, side, angle, are these ringing bells for y'all? Side, side, angle, yeah. And then the last one is side, side, side. Yes. All right. If we have this information, we can use it to calculate missing parts of the triangle using law of sines. Okay. What's an oblique triangle? An oblique triangle is a triangle that is not a right triangle, correct? So any triangle that is not a right triangle is oblique. The measures of the three sides and the three angles of a triangle can be found at least one side of any other two measures are known. So as long as you know three pieces of information, you should be able to find the rest. Okay. Now these are our different cases. So case number one is your side angle and angle side angle. You know, one side and two angles. Case number two is your side angle, your two sides and one angle, not included between the two sides. This will be 7.2 because this is what we call our ambiguous case. So that will be in 7.2. That's our next case. I like to call it don't be a donkey. Okay, yeah, I call it the donkey case. And so yeah, we'll get there. And then case three is two sides and an angle, which is the angle that's included is given. And case four is only your sides are given. Okay. And we'll be working our way through all these different cases. Yeah. All right. If we know three angles of triangles, we cannot find any unique side lengths. Okay. That's because knowing angles doesn't relate to the measurements of their sides. Does that make sense? That's because what is the interior sum of every single triangle? 180. So there's no diversions there, right? There's no difference. All right. Do not write this down. We know we don't like writing down where things came from. So before you come for me, I'm telling you, do not write this down. Just going to quickly go through and tell you where it came from. Cool? All right. So starting with an oblique triangle, either acute or obtuse, you're going to look like this, right? Non-right triangle, meaning that your height of your triangle is not, it's perpendicular to your base, right? Your height is invisible. It is not part of the triangle. Yes? All right. So from that information, they let H be your height, and then they started using what they already know about creating right triangles. So if I was looking for a side, then I would be using for the, what's that thing called? The left side of this triangle with the height at the top. So the left side here, I'll be looking for its hypotenuse, right? On this one, I will be also looking for its hypotenuse. Well, we've learned before that there's a ways to find the hypotenuse using sine, cosine, and tangent, correct? So you're using those. What you actually use here is sine. So you use sine. So you use the sine of angle A. And the sine of angle A would be H over C. So H over C. And then therefore sine of C would equal H over A. So H equals A sine C. So basically what they did was realize over and over, every time you're looking for your H, it comes down to be the opposite side times the sine of the opposite angle. And then they just kept going, created a rule, created a ratio, and here's your law of sines for you to write down. It is a ratio. Proportional. So A divided by sine A is equal to B divided by sine B, which is equal to C divided by sine C. Does this look a little familiar from geometry? Yeah? No? Maybe it's no longer in geometry. I feel like it's in geometry. Now it's just it's been a minute. All right. So the beauty about proportions is how do you solve proportions? Cross, multiply, and divide. You remember that? All right, so pretty simple math that's going to take place. Cool. All right, so the first thing you want to do is anytime they give you information about a triangle, you want to draw and label that triangle accordingly. So it says you have triangle ABC. For triangle ABC, angle A is 32 degrees, angle C is 81.81 degrees, and angle A equals 42.9. When it says to solve a triangle, that means you're looking for all missing pieces. So what is missing for us? Angle C. I swear I highlighted. Just thinking about it. Do you think it's important if we like draw the triangle? I personally think it is because it helps you keep everything in place. That's why I said first off, anytime they give you information about a triangle, draw it. So angle C, side B, and side C. So these are the things that we need to find, correct? Out of the three things that we need to find, which is the easiest? I messed up. I mislabeled. I mislabeled my triangle. What should I do? Should I just make this into a B? Yeah. Oh, that was easy. It was just typo. I'm like, wait. Oh, no. So yes, B equals 81. It should be an angle side situation. So the triangle is right. You're thinking wrong. Yeah, I just put the C there instead of a B. So angle C, basically. Yeah, so we still need everything this highlighted is correct. That C should have been a B. Yeah. All right, exactly. So the easiest thing to do is to find angle C. If I don't find angle C, add up what I know and subtract. Okay, so what is the angle that we're missing? 66. So to find C equals 180 minus 32 plus 81.8, correct? Which leaves us with 66.2 degrees. Yes? All right, after we found our angle, I wrote it in the wrong spot. We're going to now be able to find our missing sides. Okay, so we need to be able to find side C and side B. To find side C and side B, we're gonna have to set up our proportion. We're gonna do it in parts. So first we're gonna do A over sine A equals B over sine B. Okay, I thought I moved it over a little bit more than that, but I didn't. All right, so A. Remember your side is always across from your angle. So we have 42.9 over sine A, and sine A equals, I'm sorry, 32 equals, and we're looking for side B. So B is our unknown over sine of B. So sine of angle B, which is 81.8. In order to solve this, we're going to cross multiply, then divide. So to find B, what does B equal? We cross multiply and we get 42.9 times sine of 81.8. And what are we dividing by? Sine of 32. You have to keep the sign. Okay, so this is our exact answer. We're going to use the calculator to find out where. When you have a proportion, you cross multiply and divide because you have to get B by its. So Because we cross multiplied that. These are numbers. Sine of 81.8 is a number. We're trying to get b by itself. So after we cross multiply, then we have to divide by. You divide by whatever is with the variable. Whatever's with the variable is what you're dividing by. So, yes. Yep. Cross multiply, then we divide. So we're going to go to our calculator. I need to make sure I'm in degree mode. So I'm going to go to mode, switch from radians to degree. And now I'm going to input what I have. So I can't do a numerator and denominator. So I got to use parentheses. 42.9 times the sine of 81.8 was my numerator divided by sine of 32. And I get that B is approximately 80.1 centimeters. 80.1 centimeters. Okay. So now I know B is 80.1 centimeters. And the last piece that I have to solve is C. So I'm going to set the same proportion using my A. You want to always use as much given information to begin with. And so since they gave us everything about A, that's going to be our starting ratio. So A, we have 42.9 divided by sine of angle A, which is 32 degrees, equals, and this time we're looking for side C, and the angle of side C is 66.2. So again, what are we going to do? Cross multiply and all right, how are we feeling? Okay, so we need to get C by itself. We're going to get C by itself. We cross multiply, and then we're going to divide. So we get 42.9 sine of 66.2 divided by sine of 32. And what is your approximate value of C? 70 what? 74.1 centimeters. And now you have solved this triangle. Yeah? Okay, this is our baseline. How do you feel? Okay. All right. So this again is an example of side angle angle or angle angle side, however you want to read it. Doesn't really matter. It's just that when you're giving two consecutive angles and their side that follows. Does that make sense? All right. Next. I did all of that. Recap. We did it. Okay. When I said in there, make sure that you're using as much given information as possible. Okay. You notice how we solved for B and we found B, but we didn't use that in our next ratio. We still use the given information to finish the problem out. Okay. All right. Let's put it into a real world or possible word problem setting. You have to draw the problem, right? Yes. You don't want to draw the water and the beach? Why not? I meant like write the word. No. An engineer wishes to measure the distance across the river. He determines that C equals 112.9 degrees, A equals 31.10 degrees, and B equals 347.6 feet. Find the distance across the river. Okay. So he wants to know what is the distance across the river, which means that we're looking for what? A. Does that make sense? So we need to find A. All right. That's our goal. Well, in order to find A, we got to figure out what we don't know. Well, how am I going to find angle B? I know side B, but I do not currently know angle B. How do I find angle B? I'm going to add in, subtract, right? So when I add and subtract, we now get that angle B equals 36 degrees. Where are you going to All right. So now, do I have enough information to set up to solve for A? I do, right? So to set up, we have A, is that what we're looking for? And what is angle A? 31.10. What is side B? 347.6. And then we found angle B, and angle B equals 36. So now I am in the boat to cross multiply and divide. Okay. So I'm going to cross multiply. We get 347.6 sine of 31.1 divided by sine of 36. Cross multiply and divide. Oh. So then you'll get the approximate distance across the river. Does anyone need to see me put in the calculator? Are we okay? We're okay? All right, what's my approximate distance across the river? 305.5 feet. So the difference here this time with angle side angle is that just how our ratio is set up, right? Was the process any different? Do we have to really do anything else besides set up and cross multiply and divide? No, we did not. That's the beauty of being given two angles, okay? It makes it a little easier for us. No, not yet. Well, yeah, technically, side angle side is coming up. We're not doing the donkey until tomorrow. Yeah, SSA.
See, I told you.
Wow. On this one?
I just don't want to draw a line. I have to write on it.
Oh, okay. All right. No, this is called bearings, and bearings work a little different when you're drawing. Bearing is referring to your cardinal directions, north, south, east, west. Do we know what those are? Okay. Is anyone in physics? Have y'all did bearings in physics?
Yes.
Okay. I was like, y'all should have done bearings in physics. So these words should not. Yes. So if you are north, that is going to be, you know how our unit circle starts normally on the x-axis? When you're talking about bearings, you're looking at it starting at north as your 0, right? And then it goes in the clockwise from north. Yeah. If you from physics, that's something hopefully we've correlated. So it says here that two ranger stations are on east-west line 110 miles apart. So here are my two stations. They're 110 miles apart. A forest fire is located on a bearing 42 degrees from the east, from the east station. East from the western station, I'm sorry. And at A and bearing here, and then at bearing north 15 degrees east from the eastern station at B. So when I said east, I was at the north, and then I went 42 degrees towards east. Does that make sense? So from this tower, I'm going to go, this is north. I go 42 degrees east, and from my sight line, that's where the fire is. If I'm at this tower, here's my north, and it says I'm bearing 15 degrees east from this tower, and that's where I can see the fire at. Yes? Are y'all still with me? Okay. So once this is approximate to the nearest 10 miles, how far is the fire from the western station? So we need to find B. So we're looking for this guy. How far is it from that top, from the western station? Okay. So with bearings, to find when you create a triangle, you have to use the complementary concept. Complementary angles mean that they have to equal what? No, 90. Complementary means they equal 90. Supplementary means they equal 1/8. So we're going to find the measure of our angles in the triangle. Okay. So in order to find our first measure, we know that from here to here, that this has to equal 90 degrees. So if this is 42, what does this piece inside have to be? 48. So does that make sense why angle A is not 45, but 48 degrees? Yes? Okay. Now, angle ABC is a little different. Angle ABC is a little different. That's because it's not directly only on this angle. You have 15 here, right? And then you have a whole nother 90 this whole thing equals 90, correct? So when you're adding it together, it has to be the 90 plus the 15 because it's not quite perpendicular. So it's 90 plus the 15 because that angle goes a little bit further out. Does that make sense? Who said no? Okay. So right here, notice how this angle was coming into the 90. This angle went out past the 90. So it has to be 90 plus the 15 makes up angle ABC, which is angle. If it was on the other side coming inward, like this one was, then that's why we subtracted. But because it's moving away from that 90, away from the inside of the triangle, that's why we're adding.
The degree or
the degree. The angle itself is moving outside. So look. This right here is 90 degrees. Like if I didn't have this piece, this would be 90, correct? But because this piece now added 15 degrees to that angle. So that's why we had to add the 90 and 15 to find the angle measure of B. Yeah? So that's why B is 105 degrees. Yes? All right. Okay, now, because we know angles A, B, how do I find angle C? Add and subtract. So angle C comes down to being 27. Okay, so angle C and side C are my given information with the most given information, correct? They're my most original. So they're going to be my ratio that I use to solve for the missing piece. Yes? All right, and all it wants to know is what is the distance from the west tower to the fire? So do I have to worry about solving for the other side? No. So my proportion is going to be B over sine B equals C over sine C. So we do not know B, but we do know angle B, and angle B is 105 degrees. Okay. We do know C. C is our distance between A and B, and that's 110 miles. And then we do know angle C, which is 27 degrees. And all I have to do now is cross multiply and divide. So I'm cross multiplying. I have 110 sine of 105 divided by sine of 27. And then it'll give me an approximate value of how far is the west tower from the fire. The 110 is the measure angle for angle B, the whole angle. Remember we talked about this has to be 90. And I went 15 more. Oh, 110. Oh, sorry. 110 is right here. Because it's across from angle C. Yeah, remember your sides are always across from your angles. So we have the west tower is A, the east tower is B. So therefore the fire is your C. 110 is the measurement, the side, miles. Angle C is 27 degrees.
Okay.
This is your A, your B, your C. No, you're good.
And then you just
Cross multiply, divide. Yeah, exactly. Yep. All right. So 110 times the sine of 105 divided by the sine of 27. What do we get? 200 what? Yeah. It's 230. Give me a decimal. Okay. How are you feeling about that? Applying the law of sines. Okay. This is why it's very important for you to draw the triangle. Draw the triangle. Draw the triangle. ABC. Okay. All right. Up next, our second formula or second group of formulas is the area of a triangle, side angle side. Okay. So we've learned that to find the area of a triangle is base times height divided by 2. Now, what if you're not giving your height? What do? You quit, right? No, you don't. You use the law of sine. So this is your area formula based on the law of sines. It's only for sine. We have law of cosine, yes, but not today. Nope. Only law of sine and law.
where is BP? Oh, like the side.
Side. So it all depends on what you're given information. Does that make sense? Okay. It's always going to be, this is the pattern of it. It's the angle and it's not its opposite sides. Does that make sense? It's the angle and not its opposite sides. It's the angle and not its opposite sides. Okay. No matter what, that's what's happening. It's the angle and not its opposite sides. So whether you label it weird or whatever, just remember, it's the angle and not its opposite sides. Okay? All right. All right. So that's what it is. Now, here we go. Up first, we have this beautiful triangle. To refresh our brain. Oh, from chapter 1. Oh. Yeah, so welcome. All right. So as you can see here, the first thing we want to do is put our angle in what? In a decimal form, right? That's what you feel the need to do, but it's okay. Don't do extra work. We'll just put it in the formula. Okay. So we're gonna write it. We can work it just fine. You don't need to convert first. Don't freak out. You just got to remember that 1 minute equals how many, what is it? What's the relationship? It's 60 seconds. But in terms of a degree, if I wanted to go from a minute to a degree, what are we doing? We're dividing. We are dividing. It's 10 divided by 60. Okay, keep that in mind. All right, so key thing here. In order to use the area formula, it's the given angle and the sides that are not opposite, right? So the sides that make it an angle. Yes? All right. Do we have the information that we need? Yes. So the area equals 1/2, and side A is 34 degrees, 34 feet. Side C is 42 feet. And we're doing the sine of B. Now, because B is given to us as degrees in minutes, in the calculator, we have to write it as 55 plus 10 divided by 60.
We can't just put it in there with the degrees and everything.
You can't put it in there with the minute. The little 55 degree. Mm-hmm. Okay, but do you see how we're putting in the calculator? So this is telling me 55 degrees plus 10/60th of a degree. Okay, so I go to my calculator. Come on, silly. And I'm going to put it in 1/2 times 34. That's not a 4. Times 42 times the sine of 55 plus 10 divided by 60. And hit enter, and we get our area is 586.06 feet squared. So area equals 586.06 feet squared. Now, was using the law of sine area formula that bad? It was not.
Well, are we gonna have to like do the opposite, like never mind.
Like use it to find something missing?
So,
But you would have to do that.
I mean, at this point, if it came up, you should be able to get a variable by itself. I would hope so. I believe in your abilities to that point. All right. So here we have it. Find the area of the triangle. What's your problem? Minutes. What else? We don't have enough information, do we? We do not. So whether you're using, whether you wanted to use angle A or angle C, we still don't have enough information to solve, right? Because you have to have its sides that make that angle, correct? So if we wanted to use sine of C, well, we're missing side A. If we wanted to use sine of A, then we're missing sine C. So either way, we would have to find missing information. So the first piece of information that we need to find in order to make this work is we have to find angle B. Because in order to lead to the law of sines, I need to have one perfect ratio. And currently right now, do I have a perfect ratio? No, but I can find angle B. And how can I find angle B? I add and subtract. So it's 180 minus 24 plus 40 out of 60 minus 52 plus 40 out of 60. Because I have to take into account that those are minutes, degrees, and minutes. Does that make sense? I'm going to go to the calculator and I'm going to do what it says. So in the calculator, I have 180 minus, and you can write it without parentheses as long as you remember that the minus goes to everything inside the parentheses. Does that make sense? So minus 120, not 124, minus 24 minus 40 divided by 60 minus 52 minus 40 divided by 60. The calculator will automatically do PEMDAS. So it will do the division first and then subtract. Okay? Because that's what it's programmed to do. So when I hit enter, it's going to give me the value of B. And B is approximately 102.67 degrees. If you want to do it in multiple steps, all means. But at this point, just to show you how to kind of solidify your work. All right, so if I have 0.667, what fraction is that? Friendly fraction. 2/3. So we know that it's 102 and 2/3. That's the measure of angle B. What'd you get? Minus 24 and minus 52. I know. I'm trying to see where you may have mistyped. So it should be, yes.
Is the fraction the
You got
degrees
290.
or do we,
No, I'm not going to be a 4-year-old boy.
Oh,
or can you put it into like minutes?
excuse me again?
Could you put the fraction, the 2/3 into minutes?
Yes, you just have to rewrite it again when you put sign B in.
Okay.
Yeah.
Why can't we just keep it as something?
Because it wouldn't be the exact answer. And so when you have a fraction, a friendly fraction decimal, it's going to expect you to put it in as exact, or your rounding will be off in the end.
But then I put it in and I got 96. Does that get the same? Yeah.
Did you make everything minus?
Oh, we're gonna work. Hold on.
Oh, correct.
Yeah. So then, what do I do?
So that as a decimal. That means this is 102 and 2/3.
So that's my answer.
No, that's part of the answer, so that's a fine side A. And then we do lobster.
That was what?
That was the fine angle B to set up our ratio. So now we know that angle B is 102,
Why couldn't we keep it in a?
because it's gonna want you to do the exact values as much as you can when given a problem.
The decimal.
No, those are, you would have to approximate because it's a repeating decimal. 0.666666666. You could leave it in fraction form. The 300 something. If that makes you feel better. All right, so now we can set up our proportion using B in its side. So using B over sine of B, that gives us 27.3 over sine of 102 and 2/3 equals, and I'm going to find A. So A over sine of 24 and what's 40? Also 2/3, right? That's 40 over 60. It's 2/3. So to find A, we cross multiply and we're going to divide. So we have 27.3 times the sine of 24 and 2/3 all over the sine of 102
Where'd you get 20?
2/3. 40 over 60 becomes 2/3. 40. if you have 40 over 60, that equals 4 over 6, which equals 2 over 3. I just didn't want to write 40 over 60 again. For 40 minutes, degrees,
so
minutes.
We really could have done sine 24, 40 over 60.
I just reduced it so I wouldn't have to type more things in the calculator.
That's okay.
Yeah.
Um,
Okay, so now we're going to cross multiply and divide. So when we cross multiply and divide, we get parentheses 27.3 times the sine of 24 and 2/3 divided by the sine of 102 and 2/3. Notice every time I say and, I have to put a plus sign. And we get that the value of A is approximately 11.66. I'm gonna go 11.678.
24 2/3 in the calculator.
24 plus 2/3. There, anytime you say and, that means it deserves a plus in the calculator. Okay, so now I have plenty of information, enough information to solve for the area. I got 11.678. I have an angle and it's two sides that make up that angle. So now I can find the area. So area equals 1/2 A times B. It's going to be 11.678 times 27.3 times the sine of C, which is 52 and 2/3, because 40 over 60 is 2/3. Hello? So in the calculator, it goes. I'm trying to put,
You don't have C, right?
yeah, we don't need C though. So that's why we're using angle A. So we wouldn't have to waste our time trying to find additional unnecessary. I can't write anymore. It won't let me. No, there we go. Sorry. I'm gonna go to the calculator. So in the calculator, I'm gonna write 0.5 times, and I'm actually gonna go ahead and grab my answer, so it's right there. And then 27.3 sine of 52 and 2/3.
How did we get C?
Which C? Side? Angle C?
Sine.
Angle C was given to us. It was given to us. It's at 52 degrees and 40 minutes. We had to find our A, and our B was given to us, and our C was given to us. So once we put in the calculator, we get area is approximately 126.74 centimeters squared. And that concludes 7.1.
You rounded in 7/4.
7.4.